Welcome to the lesson on angle properties of a circle. So in this topic, we are going to look at these are the content and these are objectives. So by the end of the topic, the learner should be able to achieve all these objectives that are here. So you can go through them, identify an arc and so on, all the way A up to F. So all these are the objectives that you're going to cover. Then for the content, we're going to look at this content that is here. So this is the content: arc, chord, segment, B, angle subtended by the same arc at the circumference, and so on. So all these. So let's begin with the introduction, and we are going to define what is an arc, what is a chord, and what is a segment of a circle. So let's begin with an arc. So an arc is any part of the circumference. Any part of the circumference. Now let me explain using this circle that is here. Now when you talk of an arc, we have two major types of arcs. We have one that is major arc, so we have this major arc, and then we have the minor arc. The minor arc. So when you look at this circle, the major arc is arc AQB. AQB. So from here all the way, this one, shade it, this one. So that one is the major arc. Then the minor, for the minor arc, this is the minor arc. This is the minor arc, because you said that an arc is any part of the circumference. So that is the first thing. So arc and segment. So you're through with that. So let's go to the other term that you're going to find in this lesson, that is a chord. So a chord is a line joining any 2 points on the circumference. Chord divides the circle into two regions, chord segments. Chord segments. The larger one is called the major segment, and the smaller one is called the minor segment. Minor segment. So a line joining any 2 points on the circumference. Any 2 points on the circumference is what we refer to as the chord. Now, looking at this diagram here, this is the chord. This is the chord. Chord AB. Any line that join any 2 points on the circumference. So this line AB is what you call the chord. And when you look at this chord, it divides the circle into two sections, which you call segments. So this is the major segment and this is the minor segment. So that is what you call a chord. Now let's go to, after knowing those definitions, let's go to the angle at the center and angle on the circumference. This is the first property that you're going to look at. So the property which states the angle which the chord subtends to the center is twice that it subtends at any point on the circumference of the circle. So let's look at this property. Now when you look at this circle, you have an angle here and you have another angle here. So this angle 2A is twice the one that is subtended here. So this is the chord AB. So this angle A is subtended at the circumference by chord AB. So it is subtended by chord AB. Then at the center we have this 2A. So you realize that this angle here is twice the angle subtended at the circumference. So that is the first property. And the property that you've said that the angle which the chord subtends, to the center is twice that it subtends at any point on the circumference of the circle. So that is the whole meaning of that property when it comes to the diagram. So this angle is subtended by this chord, the circumference. Then at the center we have this is center O. This angle is twice the one that is subtended at the circumference. So you may have it in different forms. So this is the angle at the center, and then this one is the angle at the circumference, and this is the chord. So this angle is twice the angle subtended at the center by the chord, but the same chord is twice the angle subtended at the circumference. So this is another diagrammatic illustration of the same. So angle in the same segment. This is property number 2. Angle in the same segment. Angles subtended on the circumference by the same arc in the same segment are equal. Angles subtended on the circumference by the same arc in the same segment are equal. Also, note that equal arcs subtend equal angles on the circumference. Now, diagrammatic illustration of this statement is here. So we have this chord. This chord subtends 2 angles. You can see the same chord subtends 2 angles at the circumference. So this angle. So what we mean is that if we have the same chord subtending 2 angles, or can be even more, can be even 3 or 4 or 5, there can be many. So I've just let's look at these 2. So this angle is equal to this angle. So that those angles are equal by the fact that they are subtended the circumference by the same arc, okay, by the same arc, and in the same segment. Or you can just say they are subtended at the circumference by the same chord. This is the chord, and these are the angles. So there are 2 ways in which you can describe that angle. Either you can say the angle subtended at the circumference by the same arc in the same segment, or they are angles subtended by the same chord. This is the chord at the circumference. They are subtended by the same chord at the circumference. So these 2 angles are equal. Now let's go to cyclic quadrilaterals. You know what is a quadrilateral? It's a 4-sided figure. So quadrilateral with all the vertices lying on the circumference are called cyclic quadrilateral. So quadrilateral with all the vertices lying on the circumference of a circle. Now, angle properties of a cyclic quadrilateral. 1. The opposite angles of a cyclic quadrilateral are supplementary, hence they add up to an 80. Then, if a side of a quadrilateral is produced, the interior angle is equal to the opposite exterior angle. So let's see in a diagram what we mean by those 2. So this is a cyclic quadrilateral. So we have the quadrilateral there, and then all the vertices are touching on the circumference. So what do you mean? The first property, opposite angles are supplementary. They add up to an 80. So if I take B plus D is equals to an 80. If I take A plus C is equals to an 80. That is the first property. Then when you extend this exterior angle, you can see there is an exterior. If you draw a line here and you extend, this one is an angle that is outside here. This exterior angle is the same as, or is equal to, opposite interior. You can see also this one angle A is equals to this one. So that is the second property, the exterior angle property. Now let's look at this example. Sorry for this. Let's go to the second example, or the first example, sorry. So in the figure below, ADE is 120. Find angle ABC. So ADE is 120. ADE, ADE. So this angle here is 120. So this is 120. So you're supposed to find angle ABC. Angle ABC. So you find this. So when you look at this, this is the second property, that this exterior angle is equals to this interior opposite angle. So if this is 120, this one should be 120 also. So solution using this rule, if a side of quadrilateral is produced, the exterior angle is equals to the opposite exterior angle. Okay, the interior angle is equals to opposite exterior. So these 2 angles are equal, and both of them are 120 degrees. Angles formed by the diameter to the circumference is always 90 degrees. This is another property. Angles formed by the diameter, the circumference, are always 90 degrees. So if this is the diameter subtends an angle of 90 on any part of the circumference. So this one is 90. It can be in any part, it can even be on this part. So even if we draw it on this side like this, I'm sorry, so this one again will be 90 degrees and so on. So you may have it drawn in different forms.